Good afternoon, ladies and gents. By the survey I gave you guys last class or the class before, overwhelmingly people said they prefer to have notes delivered via video and just time to actually absorb them going at their own pace. So that's what we're going to try again today. Now, this is not going to be something we'll do every single time, every single day, but we'll try it a few times, see if it's actually working really well. So we're moving on to something new, something called transformations, and this is going to harken back, hopefully some memories from, probably middle school where you guys learned some of the very basics. We're gonna start there. We're gonna push forward as we go into this new unit. So please take a moment and catch up with me. Maybe pause the video so you can kind of get the structure set up. But the essential question we're dealing with today are what are the structures and rules that map a pre-image to an image in a rigid transformation. There's a lot of vocabulary there, and so that's what we're going to jump into first, kind of dealing with that vocabulary. Just like the last set of notes, the first important question is what are the terms we're dealing with when we're talking about this new topic. So the first term I want to talk about is just transformation itself. Transformation is a general term, and it means a lot of different things specifically, but it's kind of like a blanket term that refers to anything that takes one thing, like a point line or a shape, and maps it or copies it to another location, whether you're dealing with a grid or not. Now, when we say the word copy, the copying just can't be random. It has to happen by a ruler structure, which means the movement is not just kind of like, hey, let's just take one thing, put it somewhere else. There's a reason we're doing it, and it's a very set procedure in how to do it. Now, one thing to kind of pick up on what I mean by this, let's say I have this triangle. I'm just going to call it triangle ABC. So I'm just going to label the vertices, okay? So this triangle is going to get moved in some way. It's going to get copied to some other place. Let's say it gets copied here. Now, one thing you have to know as far as notation goes, if we're copying a point and putting it somewhere else, and we did it by a mapping, a ruler structure, um, it's no longer going to be called A, but instead going to be called A with a little mark above it, and we call that A prime. So let's say that's A prime, let's say that's C prime, and that's B prime. And so what we're really going to be studying this in this unit, or this is a small version of a unit, is going to be if I take this original triangle and I map it, how do I know how it changed? We can make some very kind of like subjective opinions, like it's maybe twisted, maybe turned, maybe slipped, but we're going to look for a lot more formality than that. And so the one thing to take away from this first definition of transformation is that the mapping, the copying has to be very formal. And then if you have the vertices A, B, C, they're going to copy with prime markings. The prime, this little tick mark, meaning that's been copied from the original. Let's talk about pre-image and image. So the definition of pre-image and image is original shape and its copy. And the original shape is what we call the pre-image, and the copy is what we call the image. Okay? And again, the terminology is very formal, but this is all it means. It just means that it's the original shape, and if we talk about the image, we're talking about the copy. And so again, like this would be like triangle ABC, and then the new thing will be like triangle A prime, B prime, C prime, because those primes again are going to be how we can mark the image. Okay. So that's all we need to know for pre-image and image. This one refers to the original, one refers to its copy. When we talk about a coordinate rule explains how to transform points on a coordinate plane. And so this is actually going to be, again, by points. And so there's usually a particular form which this rule ends up looking like. And so, for example, if I show you a rule that says like x, y, that's going to be like my original point. Okay? And then if I move it, x, y is going to transform into, because that's what this little marking means, transforms. Okay? And then we have to give it a second part, and we have to identify how it transforms. So let's say this transforms by x plus 4, and then like y minus 2. Okay? And so that literally means we're going to add 4 to x's, and then we're going to take 2 away from y. So subtract 2 from y's. Okay? So if we look at this kind of in action, if I had this rule xy transforms into x plus 4, y minus 2, if I have like 4 comma 3, this will transform into 4 plus 4, which will be 8. and then 3 minus 2, which will be 1. If I had another point, let's say 0 minus 10, that'll be 0 plus 4, so that'd be 4, and negative 10 minus 2, which would be negative 12. And so all coordinate rule does is actually show the mapping, predict the mapping, and the key here is that's got to be on a coordinate plane. And keep in mind, a coordinate plane is just like an XY grid. That's all it is. And so you have points on the grid. The coordinate rule tells you how to move them. Structural rules are a little bit different. It's going to use a bunch of different things. It shows you using points, lines, vectors, segments, bisectors, angles, circles, a whole bunch of stuff, how to transform shapes on and off the grid. So it's not going to be like a rule like with X and Y's. This is going to be more like connecting the dots. And so let's say I have, again, this triangle ABC. And it transforms, just let's say this triangle right here, ABC, or A prime, excuse me, B prime, C prime. The question here is, how did it get there? And how can I show that using lines or vectors, or whatever kind of thing I have at my disposal? So how can I show it's moved from one point to the other? Okay. So that's all it means. Like, how can I actually show by points, lines, and planes how the thing is moved? I've used the term map several times, so it's probably good that we had the definition there. Mapping refers to a formal process, albeit maybe sometimes a crude one, of copying one point to another by a structural or coordinate rule. So in other words, what I've done here in these two previous examples is an example of mapping. I'm just showing you how things got there, how things moved from one place to another. Okay. So in terms of the transformations, there are three that we're going to study in depth. So translation, reflection, or rotation. So you might hear this might hear this called translate, reflect, or rotate. And let me get that word in there. Okay, just another word to call it by. And I'm not going to really add much to this right now. I just want to kind of talk about it a little bit. So translate means you're sliding. So you're moving things kind of like you're pushing a chair across the room. You're not going to be rotating, you're not going to be reflecting it. This is just kind of a push or a slide. When it refers to reflection, it's basically going to be a flip. It refers to moving a shape by moving it, like flipping it, like literally moving it over a line. And so like this one might demand a little bit more of a visual. And so let's say I have like, let's say I have like this face right here, and I want to move it across this line. So I'm basically going to be flipping over the line in the same way like you see a mirror image. Okay? And so that's going to be kind of like your reflection. Whereas like a translation, if I can just copy this. So translation refers to more like me starting here and then ending up over there. And so I just kind of moved it in that direction. As far as like a rotation, it's a spin. That's what the word rotate kind of means. And so if I'm going to move this guy, I'm going to move it because I'm spinning it. Now this is probably the hardest one to actually kind of draw out, but it'd be something more like this. Okay? And so I'm spinning it kind of in a circle going in this direction. And that's really where I want to end the first part of notes. There is a couple things to think about, so please don't stop the video yet. And so the big thing is how can we tell something's been transformed, whether that be by translation, reflection, or rotation. There's a bunch of terms that kind of relate to that, like transformations, pre-image, image, coordinate rule, structural rule, so on and so forth. But the two big questions you're dealing with now, and this is really where the work starts, what are the coordinate rules for translations, reflections, and rotations? What are the structural rules for translations, reflections, and rotations? And so that's what you're going to be doing in the next few pieces of work. And so the next thing I have for you is a series of 3 different investigations where I want you to think about very carefully what it means to do the translation, reflection, rotation, but always in the back of your mind as kind of like your learning target. What are the coordinate rules? What are the structural rules? How can you tell this thing's actually happened? Okay? So that's the notes for right now. You don't have to write a summary because there are more notes coming in part 2. This is enough just to kind of get you started on the subject. Okay? So clean up your notes. When you're ready, ask me for the next couple investigations and we'll get you started. So thank you.